So previously we looked at point slope form in order to graph to find the equation of a line given the slope and a point. Now what if we were asked to find the equation of a line that passes through 2 points. So for example, what if we were asked to find the equation of a line that passes through the point -2, 4, and 1, 2. So we're going to label these guys over here. I'm going to label this one as my x1, y1, and my x2, y2. Now, I'll write on the side, I'd like to write my point slope form. So it's y minus y1 is equal to m times x minus x1. And right below it, I want to define what our slope was, which, as stated earlier, was the change of y over the change of x. So y minus y1 over x minus x1. So this is the information that we're going to have to use and apply it to the information that we're given. So we have 2 points. Now with these 2 points, what we would like to do is find the slope of this line, or slope between these 2 points. So we're going to directly apply it to this equation over here. So we're going to have m is equal to change of y, so y minus y1. So right here we're going to apply our y. We're going to place y2, which is 2, minus 4 over our x2, which is 1, minus -2. So notice again, we have subtraction followed by a negative number. So 2 negatives become a positive. We'll apply that right away. And we'll begin by subtracting. 2 minus 4 is -2. 1 plus 2 is 3. So our slope is -2/3. One thing I'd like to point out is that this negative sign can apply either to the top or to the bottom. So it could apply to our rise or to our run, but never to both. So just keep that in mind. Now next, now that we have the slope, we can use point slope form and take either one of our points in order to figure out the equation of our line. So we'll proceed with applying point slope form. So we have our y1, which is 4, is equal to our slope, which is -2/3, times our x minus our x1, which is -2. So yet again, we have a negative sign followed by a negative number. We'll change those to positive, and we'll begin by distributing. -2/3 times x gives us -2/3 x. -2/3 times 2. I will actually write that out so that we can see what's going on there. I will change the 2, make it over 1, and I'll just drop this down. -2/3 x. -2 times 2, I'll multiply across, we get -4. And then 3 times 1 gives us 3. Now we have y minus 4. Next, we want to add 4 to both sides in order to isolate the variable. So I'll have y is equal to -2/3 x minus 4/3 plus 4. And I will rewrite 4 as 4 over 1. Now, in order to combine these two terms, I must establish a common denominator between them. So I have 3 and 1, and the least common multiple is 3. So we're going to multiply 4 over 1 by 3 over 3. And this can be viewed as a big 1. So it doesn't change the identity of this number. This is still 4 over 1. So we have y is equal to -2/3 x minus 4/3 plus 4 times 3 gives us 12. 1 times 3 gives us 3. And now we're able to combine these two terms. -4 plus 12, that gives us 8. It's a positive over 3. And we have y is equal to -2/3 x, 8 plus 3. Now we're going to go a step further and we're going to plot this guy. Right. So over here, I'm going to label my x-axis, over here I'll label my y-axis. And just as before, when we're given an equation in slope-intercept form, it's really easy to translate this onto a graph. All we have to do is plot the y-intercept and apply the slope to it. So the y-intercept is 8 over 3. That is roughly a little bit 2 1/3, I believe, or 2 2/3. So here's 2, 2/3 would be roughly around here. We'll approximate it over there. Now we're going to apply the slope, which is we can either go down 2 and over 3, or we can go up 2 and to the left 3. So see that the negative can only be applied to either the top or to the bottom. So our rise or our run. So I'll do both cases so that you can see it. So we'll begin with applying the negative sign to our rise. So we're going to go down by 2, 1, 2, and then we're going to go over 3, 1, 2, 3. We have this point right about there. And now, starting from the y-intercept again, I'm applying slope. But this time, I'm going to apply it to the bottom, to the run. So instead of going down 2, we're going to go up 2. And now we're going to go to the left 3. So 1, 2, 3. And that's like about right there. Now, we can connect our line. And just like that, we were able to translate this information into the equational line, and then from the equation line, we were able to graph it. So this is it for this section.